Andrej Karpathy was a guest at the Sequoia AI Ascent Summit, which is, I believe, a summit that Sequoia is doing for their own investors and investees. So I want to mention a few things that he said. Always interesting to hear from him where he thinks things are going. And he made a few comments about some of the maybe driving factors, or as he calls the big rocks that can be turned in the area of AI. I think one thing is he's talking about some of the compute challenges that are still prevalent, such as sparsity, quantization, precision, like things along those lines that can be improved. That's something that NVIDIA is working on a lot, that have improved the wall clock time for workloads, or cost per token or cost per unit of training. It helped reduce that. So that's one thing he mentioned. He mentioned the difference between diffusion models and autoregressive models, something that's beyond my understanding, but I want to just note this. And I'm working right now on a course by Peter Beal about unsupervised deep learning, and kind of look into that. I believe that should reveal quite a few, give a few answers to that question. He's talking, Karpathy's talking about energy efficiency, but I think most importantly, what he's talking about is the importance of reinforcement learning. I think we're converging, we meaning the community, and also our views here at Orange Capital Partners converge towards the solution of embodied intelligence is reinforcement learning. And he's also talking about the importance of self-learning. So AlphaGo Zero as the North Star for embodied intelligence. I think, to me, that's the most revealing aspect of his talk. And I want to relate that also to the Tesla full self-driving suite, and the idea of having simulation as the base for embodied intelligence learning. This is the Not Even On podcast. It's March 27th, 2024. This is Crim Telco. For the day, the fund is up 20 basis points. The market's up 90 basis points. For the year, we are down 15%. The market is up 10%. We're underperforming by 25%. So Andrej Karpathy at the Sequoia AI Ascent Summit gave a few comments that I'd like to summarize here and point out. And let me start with the most important one. So he's talking about the idea to have an AlphaGo Zero type learning environment for intelligence, in particular embodied intelligence. He wasn't specifically mentioning embodied intelligence, but I want to just sort of borrow that from him and extrapolate. The idea is that we have, we want to build virtual worlds in which intelligence can learn through self-play. In technical term, that means we have model-free, on-policy reinforcement learning. So what that means is we want to be able to actually not even explicitly tell the agent what the world looks like. Just have the agent learn through interaction with the world, and do that, of course, by having some sort of reward function design. So what we humans, what the programmer is going to do is, in particular, design adequate reward functions. Like that is where the rubber meets the road, right? Where, if we have an agent, if we have AlphaGo Zero playing Go by itself, it has to eventually converge towards a solution, and that is in a big part going to be driven by the right reward function. So this is the way we see it, and I think Karpathy makes that point also. I think it was a little bit underappreciated in the talk. The talk was more of a general kind of keynote-ish, fireside chat-ish type of talk. It's supposed to be relaxing and inspiring, and not necessarily, world-breaking, breaking news type stuff. But for us, it is breaking news. And one of the opinion leaders in the current AI ecosystem has a clear view on where he thinks intelligence should be going. It is in a self-contained self-play. What he mentions is the problem with interacting with intelligent agents, whether it's reinforcement learning through human feedback or fine-tuning in any other way. The problem is that when the human interacts with the agent, the psychologies are different. The psychology of the human is different than the psychology of the agent. And he uses a very nice example. It might be pretty easy for humans to add numbers or divide numbers and things along those lines. It's pretty easy for humans to reason by analogy, to use metaphors. For a machine, that could be very hard. Machines are just not trained like that. If you take deep unsupervised learning, the machine learns certain patterns in raw data. It finds attributes, distributions to inputs like that. That's the strength. It might not be very good at using analogies, maybe, or it might not be very good at adding up numbers, which is according also to Karpathy's tokenizer video, which I think I highly recommended, put in the show notes. Just the way you tokenize a transformer in the learning process or in the training process, could impede its ability to add numbers or subtract numbers. So the transformer then will add maybe a program just to do an addition. So it just is. Think of the AI as a very different type of personality with different skills. And it's a lot more efficient for the AI to learn on its own terms, right? I mean, this is not very different from parenting kids. I'm going through this myself now as a parent of a teenager. My son is in the process of developing his own personality, his own psychology, and my psychology and his psychology don't match in many ways, and it leads to conflict. And that's fine. Conflict's okay. But what I don't want is to overwhelm him with my stuff and then suppress his ability to learn and evolve. And I think that's kind of what Karpathy is alluding to when he's talking about AlphaGo Zero and the wish that we could have any kind of AI trained that way. It's not just that it's better, more efficient, maybe gets faster results. It's even fundamentally more desirable because an AI can learn on its own terms. So there's two examples that I'm familiar with, where self-learning in simulation has led to interesting, creative new ways by which the machine, through reinforcement learning, has learned things that the human would not have suggested it. We have Move 37 at AlphaGo Zero. Again, please go check it out. I don't want to lose time on this one. It's been documented ad nauseum. It's a move that AlphaGo used while playing Go that a human would have never suggested. In fact, the move was considered a bad move until it turned out to be a smart move. More recently, I came across Davide Scaramuzza. I think I'm butchering his name. Davide from the University of Zurich. I just had an episode about his presentation, so go check that on our website. He was talking about training drones in a drone flight competition, and to me, that's I'm paraphrasing, Vlad Koltun, who is a co-author on this paper, that this is really an AlphaGo Zero for embodied AI. And I do believe that that's true. This is really strong because this is an agent that has, through self-learning, learned to master a task that humans are very good at, and the machine's better than humans. More interestingly, what Davide showed is a trajectory of the best human flyer, and then the trajectory of the RL-trained autonomous drone. And the drone had certain moves that would not have been expected by the human. And to some extent, it would not have been possible for the human to do it because it kind of almost required like some sort of somersault. So think of maybe, you know, Crouching Tiger, Hidden Dragon, the movie, like when you're in a fight and the opponent just does, let's say, jumps over you in a somersault and then hits you, like a very efficient move that gets him the win. But it's so unlikely that you would ever train something like that because you would break your neck many, many times before you even get to be good at it. So in that sense, this drone was doing something similar, and it gained maybe a couple of tenths of seconds, which in this race is a lot. So it's a bit like a ski race. Anyway, my point here is that the machine came up with something unusual that a human would have not been able to fine-tune the machine to do. That's the point. So Karpathy is trying to get away from imitation learning and from reinforcement learning human feedback. And I believe that this is where we're going as a community in the embodied AI space. Now, what that means for Tesla is not so clear. Is Tesla ready to make that move? Is Tesla working on a simulation platform which is embedded in video-generated AI? Hopefully, we don't know. We'll see. That's a big question mark. I believe that's where it's going. I think the paper that I discussed also in one of the recent shows, Sherry Yang, the co-author on the Berkeley paper about video as the new language for embodied intelligence, I think this is the direction where it's going. So to summarize this part of the discussion, I think I was very excited to hear Karpathy talk about this. He mentioned a couple of other interesting things. One is the compute problems that we still have, which is basically how can we get down, how can we reduce wall clock time? That's really the idea. And one of the approaches is to use quantization and sparsity and precision, work with those things. How much precision do we actually need? Probably not that much. We can really cut a lot of slack out of the actual numbers that are part of the computation, and the less precision we need, the less compute, the less memory, the less, you name it, we need. He's talking about energy efficiency. Now, that's something that he's talking. Actually, I want to summarize this part of the talk really as a question that I actually posed a while ago. I'm not sure if I made a show about it. If not, maybe I should. He is fundamentally questioning the von Neumann architecture, right? And this is the first time that a scholar of his stature is opening up that topic. And it's interesting that it's coming from him. He's not a computer architecture guy. I think his PhD is within the electrical engineering department of Stanford, so he is technically an engineer, but clearly he's not that type of guy who thinks about engineering aspects of the hardware. And he has a cross-stack thinking. When you look at his videos about I believe it's transformers, yes, or even convolutional neural nets, like he's always pretty conscious about the need to let's say to write software or programs in general in a way that is more efficient for the machine. So he's conscious of the machine. He's conscious of the more efficient way to execute certain programs, things along those lines. But he certainly is not the kind of guy a la Chris 3 or 3DAO. He's not thinking, like, you wouldn't expect him to come up with flash attention or something like that. But having said that, he is mentioning it, he's thinking about it. quite frankly, he seems to me personally pretty involved in a lot of the workflows that NVIDIA is currently working on. And maybe that was part of the sort of idea while he was at OpenAI, that maybe they are rethinking the way compute is done because it's a big part of the cost structure. Or maybe it's just his curiosity, or maybe he's also in talks to work for NVIDIA. Also, he has built the stack for Tesla, so he has certainly experience in building the right infrastructure for the compute that is necessary. I think I want to summarize this part of the talk just in general. I think we should not let go of the idea that computer architecture is really in the crossroads here, that we are entering new areas and potentially even questioning the von Neumann architecture. Fundamentally, what the von Neumann architecture does, it has memory, and then data moves from memory into an arithmetic unit that then does the math, and that back and forth is costing a lot of energy these days. So that's kind of, in a nutshell, what he's questioning. The last thing I want to mention is the question of autoregressive model versus diffusion models. I'm not quite sure what he's talking about there, so this is something I just want to put a mental note for myself and for the listeners. Let's come back to this. I'm going to do some more work, and I'm happy to entertain any comments about this. What he's saying is that certain problems ever lend themselves to autoregressive models such as language, and certain problems such as image generation are better off in diffusion. We also had this interesting paper, the Wabi paper, that talked about this new sort of foundation model stack for self-driving, where they combine tokenization, transformer technology and diffusion. So they have both, and I believe they connect autoregressive models with diffusion. So I think I want to dig a little bit deeper. What does that actually mean, and why is that interesting? And I think that's also something that I hope I can answer by doing some of the classes with Peter Abil. And also, just as a tangent here, I'm also actually going back to Andrew's introductory classes and also advanced CS classes in machine learning and deep learning, just as a note again for people who are interested, because it's worth going back to the basics every now and then, because it really helps. So to summarize, I think Karpathy's appearance at Sequoia was, to me, it was pretty interesting. He said some groundbreaking fundamental new things, and like he mentioned the need for a self-contained, self-play type learning environment in a model-free, on-policy type reinforcement learning setting. In other words, some AlphaGo zero type approach towards embodied intelligence, or intelligence in general, particularly embodied intelligence. So I thought that was new to me and interesting. You're talking about the need to find better energy, more energy efficient compute, sparsity, quantization, and precision are certainly helping on that front. But we have a lot more work to do there. And then interestingly, he's talking about autoregressive models and diffusion models and how they lend themselves to different problems, and how a combination of those could be very interesting. And I think the Wabi paper actually is combining those. So I want to dig a little bit deeper into that. Thank you.